So our new goal today, excuse me, is to learn how to get the vertex form from the standard form. So we already know method number one from what we've done before. The method number one is just by factoring. So we factor if possible, and then we follow the instructions for getting the vertex when it's in its factored form. So for example, if we express each parabola in its vertex form, we would go through our process of factoring each one of these equations and getting our zeros and finding the midpoint, and then subbing that midpoint value, which is the x-coordinate of the vertex, into the equation to get the y-coordinate. So if you haven't done that, you can try that with these examples, and then you can check your work. So for the first example, I found that my two numbers that will add to -4 and multiply to +3 were -1 and -3. So my factors are -1 and -3. Prior to that, I actually factored, a -3 out of every single term. So that gave me my x-intercepts at 1 and at 3. Midpoint is at 2. I substituted that into my factored form. I could have put it into the original equation, but it doesn't really matter. My numbers here are smaller when I'm working with my factored form, so I just did that, and I got 3 as my y-coordinate of the vertex, which then, if I put it in vertex form, the a value is the same in both versions of my equation. In fact, all three versions. So my a in my original standard form was -3. My a in my factored form is -3. That means the a in the vertex form is also -3. The x-coordinate of the vertex is written in here, so it's x take away the +2, and then we have +3 as the y-coordinate of the vertex. All right, I will go ahead and solve part B, and you can check your work on that one. For part B, there is no common factor for that one, so I went ahead and looked for two numbers that would add to 16 and multiply to 28. And the combination I found that would work was the -2 and the -14. So I broke down that -16 into the -2 and the -14. And then I paired them up for a common factor and ended up with 2x minus 1 and 2x minus 7 being my two factors for that quadratic. Now that resulted in solving for my x-intercepts, which were +1/2 and a +7/2. Now I didn't show my work for that, but you could take some steps there to get the x's by themselves when you set each factor equal to 0. I only skipped the steps because I knew I was going to run out of room. I didn't leave myself enough room on this particular question. So when I found the midpoint of 1/2 and 7/2, I ended up with +2 being the midpoint. So that's my x-coordinate of my vertex. I sub that into the equation to get a y-coordinate of the vertex at -9. So when I state the parabola in its vertex form, the original a value, which was 4, is also the a value that I use down here. Then I have an x minus 2, because it's +2, squared, and then the -9 on the end. So there's my vertex form for that. Now I'm going to show you another method where you can get the vertex. It's kind of based on factoring, but it's really based on our symmetry. It's not getting the x-intercepts. What it's doing is finding two other points that are along the same y value, like the x-intercepts are on the same y value when x is 0, and then uses symmetry based on those 2 points to come up with the x-coordinate of the vertex. So sliding over to the next here, the partial factoring method, it's kind of like factoring, but only partly. It doesn't actually give you your zeros or your x-intercepts. What we do is we let the y value, the y in the equation, we let it equal c. Now c is the y-intercept, it's the constant in your equation. So I'm just going to slide down to the example I have here. My c value, my y-intercept is +5. So what I'm going to do is I'm going to let y equal +5. So I'm going to work through this example as I go through these instructions up at the top. I'm going to let y equal 5. So what that gives me then is this equation. 5 is equal to x squared minus 8x plus 5. Now, we know to be able to solve a quadratic equation, we've got to get 0 on one side and everything else on the other. So I'm going to actually just subtract 5 from both sides of the equation here. And what I have left now is 0 equals x squared minus 8x. And you'll notice that the y-intercept piece has disappeared. All right, so part B says simplify the equation, which I have just done, and solve for its zeros. So I'm going to solve this quadratic equation that I have right here. It is not going to give me the zeros of the original. What it's going to do is it's going to give me the x values that have that original parabola having the y value equal to 5 in this case, because 5 was the y-intercept. So this particular equation can common factor. I can pull an x out of both terms, and that will be true with our partial factoring. You just have to do common factoring, which students tend to find a little bit easier than some of the other types of factoring we have. Now, to get a product of 0, that tells us then that x is equal to 0, or x would equal positive 8. Now, graphically, what this is meaning is that my parabola has a y-intercept at 5, and that comes from this point right here. So 0, 5 is the y-intercept, or there's another point with the same y value at 8, 5. So if you stuck this parabola into Desmos to see what it graphs out to be, and I'm just going to sketch this really quickly here, or I'm going to try and sketch this really quickly here. What's happening is our parabola is an opening up parabola because we have a positive 1 here. We have a y-intercept at positive 5, and then we have another point with a y-coordinate of 5 over here when x is 8. So x is 0 here, y-intercept is 5, but we have a second point right here where x is 8. So if I sketch that parabola in here opening up, my parabola is going to look something like this. And based on symmetry, based on what we know that these 2 points that I've drawn in here, the x-coordinate of the vertex is going to be exactly halfway between those 2 points. So like before, I'm going to take my two x values that I found, the 0 and the 8, and I want to find the midpoint between them. So my x-coordinate of my vertex would be 0 plus 8 divided by 2. So it's like before, it's just I don't have the zeros to work with. I just have 2 points that are still along the same horizontal line. So 8 divided by 2 is 4. So the x-coordinate of my vertex is 4, and the process from here is the same. I'm going to take that x value of 4, and I have to sub that x value back into the original equation. I cannot put it into my simplified equation here because it is not going to give me the right answer. It's not the same parabola as what I started with. So I'm going to take it and put that in. I'm going to go 4 squared minus 8 times 4 plus 5. And we're going to see what we get here. I'm going to punch that all into my calculator. I'm going to get a 16 minus 32 would be negative 16, and negative 16 add 5 would be negative 11. I actually didn't punch that into my calculator. I lied. I just did it in my head. Now that gives me the coordinates for my vertex here. My vertex would now be at 4, negative 11. And that makes sense based on how I've drawn that diagram. All right, so our vertex is at 4, negative 11. All right, so now you can try part B if you'd like, or I can walk you through it. If you want to try it, put this video on pause. If you want to just go through, then continue listening. Okay, so our process is the same here. I'm just going to switch back to my blue pen here. I'm going to let y equal the c value, which is the y-intercept, which is the positive 18. I'm going to let y equal 18. So what I have is 18 being equal to negative 2x squared minus 4x plus 18. And then we simplify that equation. I'm going to subtract 18 from both sides. I'm going to take 18 away from this side. I'm going to take 18 away from the right side as well. And that's going to leave me with 0 being equal to negative 2x squared minus 4x. At this point, we can simply common factor. I'm going to take negative 2x out of both terms, and that leaves me with an x plus 2. I'm just going to double check that. Negative 2x times x is my negative 2x squared. That's correct. And negative 2x times my positive 2 is a negative 4x. Yes, I did that correctly. My x-intercepts are going to be, for that simpler parabola, would be at 0 and at negative 2. But really what that's telling me, that's supposed to be negative 2 there. Really what that's telling me is that when my y value is 18, the two x coordinates are 0 and negative 2. So just doing a really teeny little sketch up here at the top. When x is 0, my y coordinate is at positive 18, and when x is at negative 2, my y coordinate is at positive 18. So here's my negative 2 here. And my parabola is opening down, so it looks something like this. And my vertex is going to happen somewhere in between there. So x equals the midpoint between, the midpoint between 0 and negative 2 is just negative 1. But I'll show the math behind that. That's equal to negative 1. And then we sub our y coordinate, or our x coordinate, into the original equation. And we solve that for, oh dear, I'm not using my other stylus. I'm trying to be quieter because that stylus is really loud on the videos. Okay, so we sub that in. We're going to get a positive 1 times negative 2 is negative 2. Negative 2 plus a 4 is positive 2. Positive 2 plus 18 is a 20. So our vertex then is at negative 1 comma 20. And that does make sense in terms of the diagram there. Now method number 3, we're going to do on another lesson tomorrow, which is called completing the square. Part of your homework will have to do with building up our skills again for talking about perfect squares, because that is the process that we're going to use. And you'll notice that when we write things in their vertex form, so this last one that we wrote, the a value is negative 2, so I still use that. What we're doing here is we're writing this vertex form as a perfect square with a multiplication and an extra adding to it. So that's where the completing the square is going to come in with this. We're going to be able to go directly from standard form into vertex form without having to do all these steps. But for today, we're doing the steps.